Hello, I'm going to talk about the Hardy-Weinberg equation. This is an equation used to determine frequency of genes in a population. The Hardy-Weinberg equation consists of two equations. The first one is P plus Q equals 1, where P is the dominant allele frequency and Q is the recessive allele frequency. This equation is the most basic equation of both of them. So in order to get P, you have to divide the number of dominant over the number of all, meaning the population which the equation is asking you or that you're trying to solve for. And Q is the number of recessive over the number of all, the population, same as P. And one thing to remember is when you add both of these, it's always going to equal 1. Okay. So the other equation used is P squared plus 2PQ plus Q squared equals 1. And here, P squared is the homozygous dominant, the 2PQ is the heterozygous, and Q squared equals homozygous recessive. So when something important to know about this is when you square this, you obtain a percentage. So now we're going to try this problem. So in a rabbit population, 18% have short ears, and short ears is recessive for ear gene. Now we're going to solve these two questions. So what is the frequency of the dominant and recessive allele? And number 2, what percentage of the population are heterozygous for this trait? Okay, so we know Q squared, which is 18%. So now what you have to do, it is square root both sides, which is Q equals square root of 0.18, and then you get Q equals 0.42. Now you're going to solve this equation. P plus Q equals 1. We know that Q equals 0.42, so it equals P plus 0.42 equals 1. Now you subtract 1 on both sides to get P equal 0.58. So now to answer this question, Q, which is the recessive allele, it is 0.42, and P, which is the dominant allele, is 0.58. And as you can see, when you add them together, they equal 1. Okay, so now we're trying to solve what percentage of the population are heterozygous for this trait, so heterozygous. And as I discussed at the beginning of the video, heterozygous is 2PQ. And then as we solved in number 1, it's going to be 2P is 0.58 and Q is 0.42. So now you multiply these times this, which you get 0.4872, and now you're trying to make this into a percentage. So you move it over, it's 48.72%. And that's your answer for number 2.